Hello everyone, my name is Terrell Glenn, a fourth-year doctoral student in the School of Mechanical Engineering at Purdue University. Today, I'm going to present to you the work I've done with my colleagues on our system, StoryMakAR. In this presentation, I will describe our initial design process, the evolution and workflow of StoryMakAR, results from multiple single-session workshops with 33 high school students, and future work with the project. So, imagine you're the main character in a story. Let's say you're storming the castle in order to save the princess, but instead of stone, the castle is actually made entirely of cardboard, and the drawbridge on the front is actually controlled by motors, and the torches on the front are actually just LEDs. And since you're the main character, you have to be in the story too. But how would all this work? So we developed an end-to-end system called StoryMakAR that combines three applications that allow you to 1. Easily design and program customized electromechanical devices. 2. Write a story using our event-based storytelling method. And 3. Create interactions between those devices and characters in AR. Prior work in the areas of storytelling, virtual physical interactions, as well as physical and electronics construction kits have shown to help children learn and grow as a result of their use. Technology affords our youth with opportunities to express their creativity and explore their local and cultural heritage, as is the case with Shadow Story. Augmented reality technology is unique because of its blend of physical and virtual content. Prior work like Motion Beam helps bridge that gap by creating scenarios where users can have their virtual characters interact with certain physical objects. Lastly, the physical and electronics kits given by prior works like HandyMate and Makerware afford young students the opportunity to create engaging and customizable devices for play and practical uses. So, how does StoryMakAR separate itself from these prior works? Well, StoryMakAR gives users the ability to design and build their own electromechanical devices with our plug-and-play electronics toolkit and block programming environment. StoryMakAR serves as a design space for users to design their interactions between their virtual and physical content. And finally, StoryMakAR makes it easy for users in our target age group to iterate through the design, build, and play cycle by reducing the barrier of entry to these areas. We offer three main contributions with StoryMakAR. 1. Design rationale extracted from preliminary studies that show how children engage in maker-based storytelling, what they make, and the issues that arise as a result. 2. The StoryMakAR system, which includes plug-and-play electronics, an AR-enabled app that helps users create dynamic storytelling environments, as well as 2 accompanying applications, DeviceMakAR and EventMakAR, which allow users to program their own customized devices and design the interactions between virtual and physical content. And 3, the study and evaluation results of our system, which show that it can be used to easily create new and unique storytelling experiences. Now for the motivation and design goals. In order to gather and curate our design criteria for StoryMakAR, we conducted 3 storytelling challenges with students in our target age group. Students were required to collaboratively write a story, design and build characters, props, and other objects, and then present their story to the rest of the teams. In total, we had 53 students participate in this study. Participants crafted items with recyclable and reusable materials like cardboard, plastic bottles, and aluminum cans. These items were embedded with electronics and used to animate their stories. For more information about the Storytelling Challenge, please see our paper. Now for the design goals. Previous toolkits use high-fidelity materials and are costly. In contrast, we put emphasis on mixing input and output devices with low-fidelity materials to increase accessibility. StoryMakAR should engage the user throughout the design, build, and play cycle by encouraging them to explore new configurations when they're finished with older versions. StoryMakAR gives users control over their storytelling experience by altering the existing physical content or by creating their own. Users should have electronics that are ready for play with minimal configuration. And StoryMakAR should be accessible to children of all various skill sets by eliminating the need for prior electronics and programming knowledge. Next, I will describe the StoryMakAR system and show how the 3 applications work with each other. So StoryMakar is an AR-IoT storytelling toolkit that combines physical construction, electronics, and an AR-enabled environment designed to merge physical and virtual content into a unique storytelling experience. Using StoryMakar, users can construct their pre-designed physical devices with the provided hardware toolkit or design their own. Then, users can connect their electronics to our plug-and-play electronics PCB and program those devices using a drag-and-drop block programming interface. After all their devices are programmed, users can decide how they want to control the content and create new events for their story. Finally, users wirelessly pair their physical devices to an AR-enabled cell phone and bring their story to life through virtual physical interactions. Based on our design goals, we designed a plug-and-play PCB that we call the Maker Board. We designed the Maker Board to be plug-and-play because users should not be required to undergo a significant amount of training in order to connect their electronics to it. In its current state, the StoryMakar electronics library consists of the Maker Board, which is on the left, and 7 electronics modules, which include 2 DC motors, 3 servo motors, 1 sound buzzer, and 1 sensor. We do have plans to expand our electronics library with both input and output devices in the future. So, the first application in our system is called DeviceMaker. DeviceMaker is a graphical programming language that allows the user to plug code blocks, operators, and values in various combinations and output syntactically correct code in the Arduino programming language. DeviceMaker uses common Arduino commands such as digital write and digital read, while allowing users to also choose from a list of their own built-in commands for servos, DC motors, and more. In this example, our user is creating a plain device. Users create functions for each of their devices and name them accordingly. Here, our user has decided to create 2 functions called idle and taxi. DeviceMaker automatically generates a separate file that contains information for each device and function that the user has created. These functions can be utilized later on when creating their events and interactions with EventMaker, but for now, the user will simply create their functions and save their code. As stated before, DeviceMaker outputs syntactically correct code in the Arduino programming language. Each device is programmed individually in DeviceMaker, compiled and uploaded to the Maker Board via an over-the-air Wi-Fi server. For more information on DeviceMaker, please refer to our paper. The next application in our system is called EventMaker. EventMaker is an event planning app that allows the user to design the interactions that happen between their virtual characters and physical devices. Each event has an event name, which describes what is happening in the event. Each event has a subject, which is the character or device that the user controls. Users can choose between any of our 4 characters or from a list of devices. If a virtual character is chosen, users can select an animation for the character to perform during the interaction. If a physical device is chosen, then the list of functions that they programmed in DeviceMaker will be available for them to select. As this illustration shows, the plain device that our user created can be selected from either the subject or the target fields, and the corresponding functions are selectable from the drop-down menu. Each event also has a target, which is the character or device that performs an action when the subject interacts with it. Users can choose between the virtual characters or physical devices for these interactions. And finally, each event has a user interface, which gives the user control over their subject during that particular event. For more information about EventMaker, please refer to our paper. The last application is StoryMakar, which is the namesake of the project. StoryMakar is a cell phone app that wirelessly pairs to electronic devices, creates virtual tags for each physical device. StoryMakar also uses a plane detection algorithm to create a map of the room, which allows users to tag their physical devices, place their virtual characters, and create interactions between their virtual and physical content. As you can see, StoryMakar gives users the option for a default story, which only contains pre-made devices and characters, or a custom story, which they create on their own. For more information about the StoryMakar application, please refer to our paper. Now I will describe the user studies that we conducted to evaluate the system. Study participants were gathered from a summer camp that is held at the university during the summertime. In total, we had 14 students participate in our study 1. The workshop lasted 3 hours and included a pre-study survey, as well as an introduction to the StoryMakAR Structure Toolkit, Electronics Toolkit, and the StoryMakAR app. During the final half of the workshop, participants narrated their stories to the group, and the video feed from the phones were broadcast to a large screen. Students in our target age range were gathered from high schools local to the Lafayette, West Lafayette, and Greater Indianapolis communities. In total, we had 19 students participate in our second study. Again, the study lasted about 3 hours, starting with the pre-study survey, followed by use of all 3 applications, and the post-study survey. Participants were given a myriad of materials to create their own devices, including cardboard, paint, yarn, feathers, plastic bottles, tape, and more. After students designed their own devices, they programmed them with Device Maker, generated their own events with Event Maker, and brought their stories to life with StoryMakAR. Participants were able to design their own fully functioning electromechanical devices during our 3-hour study, which you can see on the screen. Now I will go over the findings from our 2 studies. So overall, students enjoyed using the system and were able to create a wide range of stories, devices, and experiences with the system, as well as each other. As we expected, groups with a larger number of students were afforded more time because they were able to divvy up the work amongst them. This resulted in a greater number of physical devices, events, or both. The engagement and collaboration between group members was most notable and appreciated. Some group members worked on separate tasks, but were engaged in dialogue throughout. Another notable aspect is that students were inclined to pass the phone to one another while narrating their stories. Other groups stayed together and worked on each part as a unit. However, the smaller groups that did this were not able to complete all of their tasks within the 3-hour time period of the study. In our paper, we go over all of the survey results, participant demographics, and other relevant information, so please refer to it, as well as our supplementary material for more. Finally, I will briefly go over some of the limitations and the future work that we plan to do. So there are 4 main areas in which we would like to address the limitations of our system in future work. First, we plan to expand and enhance our structure toolkit and our electronics library to have more devices that students can choose from, as well as more electronics to use for new electromechanical devices. Adopting a natural language processor for StoryMakAR will enhance the storytelling experience by factoring in keywords and phrases while users narrate the story. Research projects like light anchors and commercial products like Wonderscope already have this feature for their AR and storytelling experiences. As mentioned during the results portion of this presentation, our participants wanted to share the experience of telling their stories with each other by passing the single phone to one another at different parts. This frequently caused the camera to be occluded and would lose tracking. Giving multiple users cell phones for a collaborative AR experience will enhance StoryMakAR and be more engaging for users for this purpose. Lastly, we believe StoryMakAR has the potential to become a fully immersive and interactive system for youth to learn subjects like computational thinking and electronics, and we plan to explore this in the future. Lastly, I wanted to take a moment to acknowledge and thank the funding agencies from the National Science Foundation, as well as the C-Design Lab, and the hard work from other students in the Purdue School of Mechanical Engineering. Thank you. If you have any questions, please feel free to contact me via any of the communication channels on the screen, and I'll be happy to answer any questions that you may have.